And next we have Janine Jones. She was going to be a keynote speaker at our conference, and so we are lucky that she has created a shorter version of her presentation to share with us today. She's the Interstate Resources Manager for the California Department of Water Resources. So, Janine. There you
go. Okay, can you see my slides okay?
Yes, you are good to go.
Okay, all righty. Well, good morning, everyone. And speaking of our last drought, this is a photograph from our our drought. That is Lake McClure at a very low lake level. So what I'll be talking about this morning is our efforts at DWR to improve subseasonal to seasonal precipitation forecasting because it's so important for water management. Just a quick refresher on definitions. So the time period that we're interested in is the time period beyond the scale of a weather forecast, beyond the scale of a weather forecast, so typically more than 2 weeks out. And this sub S2S time period is often called the bridge between weather and climate. I also refer to it as the poor middle child of the atmospheric science community because it occupies this critical for water management time period between the weather community and the climate community. And those two communities are about as separate as, say, oceanographers and terrestrial hydrologists. And this is also a time period that has suffered from a lack of research funding, which has implications for the quality of the forecasts that are available. So just as a reminder about the historical time period here, we've been doing water management for far longer than there has been modern weather forecasting. You could say that the start of modern weather forecasting only began in 1960 with the availability of weather satellites, and skill has increased since then in forecasts. And in the mid-1990s, the Weather Service's Climate Prediction Center began production of the outlooks, so the looking ahead in the S2S time period beyond a weather forecast. And that's what I'll be focusing my remarks on. So we actually already saw this from the previous speaker. This is the Weather Service's operational product for December, January, February, our wettest months in terms of average statewide precipitation. Normally when we would get about half of our statewide precipitation. And what you see depicted here is really a rather canonical La Nina pattern with dry conditions across the southern part of the United States. But is this what we will get? That's an interesting question. And this slide is taken directly from the Climate Prediction Center's website when it points to the things that they look at when they look at seasonal forecasts and where do they derive the greatest amount of their skill from. Well, it is ENSO that they heavily rely on. And, that's a nice thought, but let's remember the Godzilla El Nino, which was a great example of a forecast at the latter part of our recent drought period, in which, based on the ENSO forecast, California was going to be very wet, but because it was a very strong El Nino year, but what actually happened was that drought conditions continued for us. So, not a useful forecast from the perspective of a water manager. And we also saw some of these ENSO graphics in the previous presentation. And in fact, they were provided courtesy of the next speaker on our agenda today, when she was at the Western Regional Climate Center. And the point of this plot being, if you just look at historical record, what does a La Nina mean for the Sacramento Valley, which is an important source of water supply for us? Well, it doesn't really say a whole lot. That's pretty much a shotgun plot. In comparison, when you look at Southern California, where we really do see a difference in wet-dry conditions between an El Nino year and a La Nina year. So looking just at historical record, we might be inclined to say that Southern California is likely to be drier than average this winter. And we really can't say much about Northern California because there's not much of a correlation in the historical record. So, and just to point out, this is the long-term skill evaluation based on a metric that meteorologists use to evaluate the skill of the tercile forecasts that are used for the outlook. I'm not going to try and explain the metric, but just keep in mind that white areas on the map essentially means you have no more skill than predicting climatology or average weather conditions going forward. You will notice that a lot of the map, including most of California, is white, and the metric goes up to a perfect score of 100. Well, kind of eyeballing the color scheme on here, I don't see anything that maybe gets beyond about 40, which if you were in school, certainly that would be a failing grade. So, the problem is this is a difficult science area, hasn't had the research funding to improve forecasting, but would be really valuable for us as water managers. And in fact, we have a long record of water managers as asking the science community for this, particularly for water supply and drought purposes. You can look back at after action reports that were done during California's largest droughts, and you find these quotes saying that, gee, what we really want is a skillful long-term forecast, well beyond the time scale of a weather forecast. So certainly not news to people in the water management community. And why is it important? It's all about lead time. If we think about what California's wet season looks like, we have lots of lead time to take mitigation actions for either shortage or wet conditions at the beginning of the water year. And we're out of lead time at the end of the wet season. At that point, all you're doing is operating reservoirs pursuant to rule curves and hopefully with FURO in place to a weather forecast. But you don't have much discretion for decision making then as compared to where you are at the start of the wet season. And we have to make decisions as water managers during the wet season and at the start of the wet season that frankly have very high dollar impact or economic impact as compared to what we can do by the time we get to the end of the wet season. So this subseasonal to seasonal forecasting is a difficult science challenge. We acknowledge that. This has very much been the poor stepchild in terms of federal research funding. And because there hasn't been much federal research funding going into this, the community of academic researchers that work in this area is really, really small. I mean, it's almost, and particularly when you look at ones who do applied work, it's almost to the point of I can count them on, the fingers of two hands, and that's only if I include some people from the European Center in Europe. So difficult path forward on this, and many of us are trying to figure out how we can look for low-hanging fruit or things to move this forward. Now, in the more recent of the two National Academies reports on this subject, which was done in 2016, they basically said, well, there aren't any low-hanging fruit. It's going to need a little bit of everything, better observations, better data assimilation, better models, et cetera, but they did express a vision, a very optimistic vision that, with the proper investments that they hoped or thought that within a decade's time, people could be using S2S forecasts the way we now use weather forecasts. It's nice to be optimistic. However, DWR's approach on this, which was begun about a decade ago, we're still working on that optimism thing. looking at it in two perspectives, one on the political side of trying to get authorization and funding for the Weather Service to specifically focus on this area and basically increase the priority of funding for them, and also to fund some work ourselves as DWR as resources have been available. And it's worth pointing out that with respect to what NOAA's Climate Prediction Center has been able to do, you know, they've certainly had budget cuts over the past decade and more, and they have primarily focused their work on working with dynamical weather models, or, you know, to use the term that Alan referred to, trying to improve the physics of the models. And they have not had the funding to continue with some of the statistical models that they used to employ, which might add value if combined with dynamical models. So we have made a conscious decision as DWR to focus on areas where research effort was not going by the Weather Service, to see if we could frankly spin up provide some seed money, spin up some pilot projects, try and move things into a position where the Weather Service could later take them on. And so in 2017, we were successful in working with a coalition to get a title added to the Weather Research and Forecasting Innovation Act that basically specifically directed NOAA to do S2S forecasting, and also required them to submit a report to Congress on what resources they needed to improve forecasts. And unfortunately, that report has not yet been submitted. So while that political track is going forward, we've been looking at the you know, small things that we might be able to fund. One of the first one of the earlier products was work that we did through a contract with NASA that involved UC San Diego as a subcontractor to say, could you identify atmospheric rivers and forecast them in global weather models? Well, okay, good step. Yes, we could do that. Can you extend this out to the subseasonal scale next? In other words, week 3, 4. And the answer was yes. We did a couple of years worth of experimental forecasts of them, but the scale was frankly very minimal. No surprise, that's what NOAA has also seen with its efforts using other techniques for precipitation forecasting at week 3, 4. Then, as a sort of flip side of that, we asked the question of, can atmospheric ridging be forecasted out into the subseasonal scale? The interest there in being that if we have persistent ridging off the coast in California, as we do during our drought years, it's not raining then. And frankly, it's as valuable to us to know when it's not going to rain as when it is going to rain. So we are currently having experimental forecasts being produced. Last year was the first year, and we'll continue that this year and then evaluate them to see how the skill has turned out and decide where we want to go with that. This is just an example of one of the experimental products produced through our contract with NASA by Scripps, a depiction of an atmospheric river forecast probability going out beyond the 14-day weather time frame into what's shown here as a blurry time frame on the left-hand side of the slide of looking at that, you know, week beyond week 2 going out to week 3. So experimental product. Another experimental product, this is the ridging product, in which there's an effort to look in 3 different geographic locations off of the West Coast and say, is there ridging there? And if there is, and if enough of the model ensembles suggest ridging is present, then what does that potentially mean for us in the Western US? And I should add that we're interested in the Colorado River Basin as well as California, because the Colorado River is a source of supply for Southern California. And also want to point out that we at DWR aren't the only one looking at this subseasonal activity. The Bureau of Reclamation has been doing a subseasonal rodeo, as they call it, a prize solver competition that targets people who do machine learning and AI to see if they have these coders develop experimental forecasts and provide the code for the winning ones to CPC to evaluate and see how these forecasts were able to beat a metric of a NOAA forecast. Switching now to seasonal, this is a piece of a product that we have NOAA Esrel in Boulder doing for us. That's NOAA's Earth Systems Research Lab. This is a canonical correlation analysis, another statistical approach to look at a seasonal forecast focusing on the Western U.S. This was just a slide from last year showing how they expected their model to perform. We don't have this year's forecast yet. I expect to get that in the next few weeks. So this is a fairly, a somewhat more sophisticated statistical model. We're also funding some simpler statistical approaches. This one by a researcher at UCLA. This specific example here is for the Colorado River Basin, using two different statistical approaches to attempt to say what's the breakdown of precipitation and snow water equivalent. And this is the first year that we've done this particular product, so we will see how it turns out and decide where we want to go with it. Next steps for us, we are actively attempting to work the appropriations process to get money for NOAA for a Western seasonal pilot project for California and the Colorado River Basin. Frankly, since the date of enactment of the Weather Research Act, NOAA has had largely continuing resolutions, which has made it difficult to get appropriations for a new start. We are planning to be working on FY22 appropriations because we need the research funding to build the community so that we can get to the point where we have better forecasts. And realistically, this won't be a quick process. It's probably about a decade plus effort, as the National Academy's report suggested. So this is where I wrap up and ask if there are any questions.
Well, Janine, this is Alan. I don't have a question, but a comment. And I would say, as a federal employee, federal agency, we can't lobby the Congress for funding for this kind of research. But having folks like DWR engaged in this has been really helpful with being able to move some of this forward. So they can lobby. They actually provide money, and so that's been a really valuable partnership that I think we're benefiting from and leveraging with other work, just people working inside of NOAA and the Weather Service on these projects that aren't necessarily funded, but we've got our folks working on it too. So appreciate your efforts in this area. Thank you.
Well, when we look at it from the big picture perspective, the Weather Service annual budget nationwide is about $1 billion a year. That's the same size as the annual budget of our largest urban water district, Metropolitan Water District of Southern California. And it's a lot smaller than our annual budget as the State Department of Water Resources. And the amount of funding that we think NOAA would need to spin up a seasonal pilot project for California and run it for a few years is probably on the order of under $10 million a year. So, we're not talking about, in terms of big picture budget issues, we're not talking about an exorbitant sum of money.
Okay, great. Thank you, Janine. There was no other questions that popped up there. Really appreciate your time.